Okay, in this video we're going to talk a little bit about standard input and a couple of different ways you can get input from your program. So standard input in the normal sense that we talk about it in terms of Python 3, as we normally use the input function and we pass it an argument, it's a string argument. This prints to standard output, right? Even though we think about the input function as getting input from the user, we also have to print out a message to the user so they know what to type, right? We leave a little space there, and then they type something, and whatever they type gets stored in this variable. And then we have another line of code. This prints to standard output, leaves a little space, they type something and press enter, that gets stored in the variable last, and then prints to standard output. Right? And so this your name is first last, pretty standard program here. And we can run this, and I'm going to call this TTY standard in. TTY stands for TeleTypewriter. All right, and so generally when we think about a TTY, that's somebody at a terminal executing the program and waiting for output to be displayed and then typing in input. It's interactive. So TTY, whenever we think TTY, TeleTypewriter, we think of someone using a terminal, a person using a terminal. So we run this, and sure enough, that argument is printed to the terminal, to standard output. We have a space here, and so now we see our cursor. Now notice it did not print a new line character there, right? So I'm going to type in my name, and when I press enter, that new line character from me pressing enter is what causes this to go to the new line, causes the terminal to go to the new line. Python never printed out that new line. It was me, when I typed in the input, pressing the return key that made the terminal go to the next line. Okay, and then here I'm going to type in my last name, and again I press enter, which both tells the input function that I've typed in something and to store it, but also it does indeed print a new line character. Now the program prints to standard output this one line. Okay, and it uses a format string to inject the first name in the curly braces and then the last name in these curly braces. And puts quotes around it. Pretty simple program, right? So what if I wanted to run this program, but I wanted to use data from a file instead of having to manually type these things in? Okay, so let's say, or the output of a command, right? So I can have the echo command, the --in option means everything, the echo will honor the new line characters. So Luke \in May, press enter. We see this prints out Luke and then a new line character and then May. Now this little %sign is what the Z shell syntax, that means that the file output ended, but it went ahead and went to a new line so that your command prompt is on a new line. But that % is telling you that there is no other character here. That's the end of the file, essentially. Okay, even though there was no % character here, right? This is just letting you know there was no new line. If I added a new line character here, you would see that. Okay, so I'm intentionally not adding the new line character here. Alright, so echo Luke May, and then if I want to use the result of this command, right? This is a command. This could be any command. I could run all sorts of different commands and get 2 lines of data, or basically a string with a new line character in between, and I could pipe that into my command. Okay, so what this is doing is saying the output of this command is going to be piped in as standard input to this command. All right. So when I press enter, look what's happened here. All right. So notice our input command, it prints out this question and the space, but it never prints out a new line character. And since I don't manually type anything and press the enter key, we don't go to another line. And then the next input is printed. And since I don't manually type anything, it's getting the input instead from the pipe. There's no new line character. And then it finally prints this last line. Now this print does have a new line character, which is why we don't see that little % sign, because print automatically adds a new line character. The input function does not. Okay, so this is nice. It's nice to be able to take the output of one command and pipe it into the standard input of another command. We can also do that with files, right? So let's say I wanted to add this data, and I'm gonna output this to a file. I'm gonna call this name.txt. Right? So I have a file in here called name.txt. Cat, what's in the file? Just Luke May, and no new line character at the end there. All right. So I can pipe this in. Well, not pipe, but I can run my program and use the file data as standard input. Okay, I can do that using the less than symbol. Okay, so this is the opposite of what we do when we output data to a file, right? So we have a command, and I can redirect that output into a file. So here I can take a file and use that as input, the standard input of a command. All right, so that's the less than symbol. All right, and if I run this, we see a similar thing happened as when we piped the data. Okay, so the main distinction here is we use a pipe when we have the output of a command. So standard output is going to standard input. So you have the command and then pipe, and then the command you want to pipe to. Right? Here, the command you're running, and then the data you want to insert as standard input, use the less than symbol and name the file. Okay, so these are two different ways of using standard input. Now there's a couple problems with what we're doing so far. Is if we have data from the pipe or from a file like this, we don't really need to ask the user for anything because it's not helpful. Once they've pressed enter, seeing these prompts as far as what data is needed isn't useful. They should already know what is needed, otherwise they wouldn't be running the command like this. Right? And this also clutters up our output. The main output we want from this program is just this last little bit. So we don't want all these extra messages. Okay, so how can we code that? How can we decide when to display that information and when not to? Okay, so this version is TTY. If you just run the program, TTY, standard input, that's going to display things so the user can see the messages about what to type in, and they can press enter, and this is the interactive mode, right? TTY mode. We need to make another program that's not TTY mode. So we can make a similar program. So this will be, we'll call it pipe standard in. Change the mode here, make it executable. You can do that with chmod from the command line. And in order to do this, we're going to import sys.standard, or import sys, and then we're going to use, spell that right, we're going to use sys.standardin. Okay, so for line in sys.standardin. Now what this is going to do, this is a for loop, it's going to iterate over the standard in file descriptor. Okay, so this does some stuff for us automatically. Well, let's do something instead. Let's do sys.standardin read. Okay, so this is going to read in all of the standard in data, and so this is going to be lines of data, and we can just print this out. We'll print out lines. All right, so this is our pipe version, and we're just starting out. We're getting stuff from standard input. So I can run pipe version, and I want to get information from name.txt. Okay, so when we print this out, name.txt has the name, a new line character, and then the last name, and then the print command adds an extra new line character, right? So that worked, and we didn't get any of the messages. But if I were to just run this in TTY mode from the terminal, we see it's asking me for input, but I have no real notion of that. So from TTY mode, I need to know what sort of data is being asked for. If I know what the program does, I can just type it in, and it'll still work, right? But one problem here is I keep pressing enter, and the program doesn't stop collecting data. So that's because when you're in pipe mode, so when you collect data like this, this has to do with at a low level how the standard in, standard out, and standard error file descriptors are read to, or read from, and written to. But you have to send it the null byte, or Control D, which is the end of file signal, and that tells the program that there's no more data in the file being piped in. Okay, so at that point, all of my data has been sent, and all those new lines are sent as well. Okay, so here's what I actually typed in, right? And then here's the print statement afterwards. Okay, so if I wanted to do this again, I would type in Luke, enter May, and then I could just press Control D and say that's the Control D. That's the end of the output, or that's the end of the input there, right? So we are reading everything from standard input, and this happens automatically. That null byte, that end of file signal is sent automatically when we send input from a file. Once the data from the file is finished, it sends that null byte to the program so it knows to stop collecting data. Same with a pipe. So I could do the same thing with the pipe command. If I had echo and I can pipe this, right? So either way, if you're using this sort of format, this automatically sends that end of file signal to the program. All right? Now I have to do that manually if I run the program myself. Okay, so this causes some issues, right? Like, what if I wanted just one program, and I wanted this program to be interactive with the TTY, so I want this to work. Or if it's pipe, then I don't want to display any of these messages, right? I want to skip that. I still want to collect the input and then print out this result, right? So I can copy and paste this. I'm going to need to put that in here. All right, so let's just finish up this pipe version. You've got these lines, and I want to get the two values. So the split list is lines.split over the new line character. Right, we're going to split that over the new line character. That's going to make a list. And then theoretically, I could have, the string could be Luke, new line, May, new line. And if that's the case, the split is going to split over the new line characters. So we would have Luke as the first item as the array, May as the second item in the array, and then an empty string as the third item. So we want to check for that, and we want to just remove the last item if it's empty, right? So if split -1 doesn't exist, so if not split -1, then split dot pop, and you could just say dot pop or specify the index. Okay, but this is just going to remove the last item if it's an empty string. Okay, and so then split 0 is going to be the first name, and split 1 is the last name. All right, so we don't need this print here anymore. So to recap, we're getting the lines from standard input, and that's going to include the new line characters that we type when we press enter. Right? If the last item is a new line character, we're going to pop off that, or if the last item is an empty string, we're going to pop that one off. And then the first item is the first name is the index 0 item in the list, and the last name is the index 1 item in the list. All right, so let's run this and make sure the pipe version is working. So echo Luke, new line May, and we're echoing that to the pipe version. Your name is Luke May. So that's good. We don't have the extra prompts, right? We don't have all this extra data that we don't want. Okay, so that works. Let's test it and make sure if we have the extra new line that it still works, and it does, so that's good. All right, so this works that way. What about with passing in data like this from a file? Right, that works as well. So this is good. We've got a way to work with the pipe standard input, and we've got a different program to work with TTY standard in. And this one will prompt us. But what if we want to combine these programs, right? What if I want both? I want to have my cake and eat it too, right? So let's make one program that joins these two concepts together and is coded in such a way that it will detect if it's a TTY or if it's a pipe type of standard input. All right, so we're going to make another program or another file. This is going to be called stdin.py, or we'll call it both underscore stdin. All right, so here we have both. We'll add our hash bang. We're going to import sys. And basically we're going to take the things from each program. So I'm going to just copy and paste each one of these in here. So this is our pipe version. And then we've got our TTY version. All right, so these two different versions, and basically what we want to do is, if we can detect somehow that there is a TTY, so that means it's a TeleTypewriter, that means there's a terminal and very probably a human on the other side of that terminal, we want to prompt them like this. The human needs the prompting. But if you're running the command by piping the data, then you probably know how the command works, and you don't want those prompts messing with the output. Okay, because this is all just printing to standard output anyway, right? And so you probably don't want that if you're not running the program interactively with a TTY. So it turns out there's a way for us to do this pretty easily. We can say if sys dot is a TTY, that's a function, and that's going to check to see if, that's sys dot standard in dot is a TTY. That's going to check that standard in file descriptor, and it's going to see how the data is coming in. Is the data coming in from a TTY? Is it connected to a TeleTypewriter? Or is the data coming in as a pipe? Is the data being piped via the pipe command, or is data coming in redirected from a file? All right, so if standard in is a TTY, then we want this stuff. Right? And then otherwise, let's got the caps lock on there. Otherwise, we want this stuff. So now we sort of have the best of both worlds here, right? So both.standardin, let's change the mode and make it executable. And now if I run this as a TTY, this should be true, and then this will occur. Right? If it's not run as a TTY, meaning I'm piping the data, this should occur, and we won't get the prompts. All right, so let's try this. I'm going to run both. So here we ran it from a TTY, and it's asking for data. That's fine. And then what if we run it from redirecting the file data as input? We didn't get any prompts, but it printed up the correct data. And then what if we run it with echo like this and actually pipe in the data like that? That works. Okay, so this is a way you can account for the different types of standard input. Standard input from a TTY, which is TeleTypewriter, which implies that there is a terminal and a user interacting with the terminal. And then the other methods would be if you're piping data. Right? So there's just an example of a couple ways to interact with standard input.